let's look at unsupervised learning. Here I have for you 6 instances, and your job is to put them into 2 groups using whatever rule you like. Just put them into 2 groups for me. Anyone? Tongue out, not tongue out. Great. So what are the labels that are going to come out of this system? Are they tongue out, not tongue out? Or am I doing some trickery? The labels that are going to come out are just like A and B, or 1 and 2. They have no human interpretable meaning. The tongue out, not tongue out is the recipe that we're going to use to separate them. The output is just like thing 1, thing 2. And so, all right, 1, 1, 1, 1, 2, 1 is what's going to come out, 2 groups. Some other way to separate them. Sitting, standing, okay. So 1 or 2? You're responsible for this, so you tell me. 1, okay, how about this one? 1, how about this one? 2, this one. 2, this one. 2, this one. 2, see? Easy. Any others? Cat selfie, not cat selfie, I love this one. All right, so, what do I hear? 1, 1, 1, 2, 2, 2. Okay, so this happens every time with every audience. You ended up separating these things. I didn't make it sound like there were right answers and wrong answers, but I'm still deeply disappointed in you because here you are saying tongue out, not tongue out, cat selfie, not cat selfie. When I, as the proud mother of these 2 individual cats, really hoped that what you would tell me is here is cat 1 and here is cat 2. But instead, look at you with your sitting, standing, and all the rest of it. And every other audience does this as well. Actually, one audience came really close to separating them, said ugly cat, pretty cat, and I was like, whoa, 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 we're going to have to talk about this later. So here is Huxley, and here is Tez, 2 individual cats. Now look, if we had done supervised learning, and I had given you a few examples of Huxley and a few examples of Tez, of course you would then go and label things that way. But I didn't tell you what I was looking for. I just said, here, take all this stuff and split it into different groups however you like, or by whatever the rule is that is part of your internal algorithm. Now, that's the thing with unsupervised learning. If I don't tell you what I want from you, I just tell you to put things into groups, I get what I get and I don't get upset, right? It's no guarantee that the system is going to come up with what is actually dear to your heart in this example. Just splits things into different groups. And so what you will do with unsupervised learning is you will look at the results and you'll ask yourself, is this something I can use for anything? And if not, kick the system and ask it to split them some other way and keep doing that, and maybe nothing dear to your heart ever comes out. It's just separating them into groups. Now there's another little cautionary tale here. See, if you are like me, these cats, they're where your heart's at. And whenever you look at photos to do with them, you see individual 1 and individual 2. And you expect the machine learning system to be looking for that because it's precious for you. And then, let's suppose the system does give you these splits. 1, 1, 1, 2, 2, 2. The human foible here is to think, look, machine learning is separating Huxley from Tesla. You'd think, right? Except maybe turns out that what it's doing is asking radiator, not radiator. And all the photographs that we took of the first cat didn't have radiator, and all the ones that we took of the second cat did. Or maybe the first set of photographs was all taken on a sunny day, and the second set was all taken on a cloudy day. Well, how do you know that this rule has any human interpretation? At this point, you don't, and you shouldn't, and you should stay cautious. If you want to ask whether there is that story in these photographs, you need to make sure that you design an exam for this system with new data, where if the system passes that exam, the only interpretation can be that the story is true. So the exam had better have cats taken on the same weather conditions across a variety of locations in the apartment. And then, if it still separates them in this way, then you have a bit of evidence to start talking about perhaps it is finding Huxley and Tesla. I don't trust that because this is what's dear to you, it is also doing this. And the other little cautionary lesson that we get here is you, humans, you're a pretty good algorithm for this. I want you to remember that you didn't find what I cared about. You didn't pull out the two cats. So a data scientist going about applied machine learning, expecting that the algorithm is going to give them what they care about, well, they are possibly in for some disappointment. And don't think things like machine learning is better than humans, so it can do things humans can't, so I expect it to work here where humans will fail. Don't expect the reverse either. Oh, humans are so good at all these tasks, they're going to get everything I care about. In fact, this whole testing thing, it holds not only for machine learning, it also holds for stories that humans come up with based on data. When you look at some data and you form some opinion, if you want to be able to take that opinion seriously, design an exam and check that that little recipe that is your opinion actually works on the new situation also. So unsupervised learning is the search for patterns. This is where you don't have any labels, and some keywords here are data mining or clustering.